Hello friend, in last lecture we have discussed the R and S configuration in three-dimensional structure in the tetrahedral type of compound. In this lecture we are going to discuss R and S configuration in Fischer Projection Formula, which having one chiral atom and two chiral atom. Let us start our lecture with Fischer Projection Formula, which having one chiral carbon atom. So, in this lecture our topic is R and S configuration in Fischer Projection Formula, which having one chiral carbon atom. As we discussed in last lecture, we can determine the R and S configuration in three-dimensional structure. In the same way, we also can be determine the R and S configuration in the Fischer Projection Formula. So our condition for this determination is the lowest priority group must on the vertical line. So as we discussed in last lecture, the lowest priority group must denoted by the dotted line. It means it must be toward the back side of the observer. So in this case, the lowest priority group should be on the vertical line. If it is not, the lowest priority group when on the horizontal line, then we have to change the configuration from R to S or S to R. Let us start this determination with the actual example. See, this is one compound which having the chiral atom. This we know that how to give the priority. See, in this compound, this chiral carbon atom having four different groups. This is the hydrogen, this is hydroxyl group, this is ethyl group, and this is the methyl group. So we can write here the first priority to the hydrogen group, second priority to the ethyl group, third priority to the methyl group, and fourth priority to the hydrogen. So we move here from first to second and second to third. It means that this is the S configuration. In this case, according to our condition, the lowest priority group, that is hydrogen, is on the vertical line. Therefore, there is no need to change the configuration. And here, the rotation is anti-clockwise. Therefore, this is the S configuration. Now, in second example, see here, there are four different groups. The one is the hydroxyl group, this is the acidic carboxylic acid functional group, this is the amine group, and this is the hydrogen. So, see here, this is carbon which attached to the next hydroxyl group. This is carbon attached to the next two oxygen group. So, therefore, and this is the amine group. So, this is nitrogen, and we know that nitrogen having atomic number 7. Therefore, this is having first priority. This carboxylic acid has second priority. This CH2 hydroxyl group having third priority, and hydrogen having fourth priority. So we move here from first to second, second to third, and third to fourth. So therefore, this is the clockwise rotation, and hence this compound having R configuration. Now, in third example, we can see here. See, this is NH2, this is CH2OH, this is the carboxylic acid group, and this is the hydrogen, out of which amine group having first priority, this carboxylic acid having second priority, CH2OH having third priority, and this hydrogen having fourth priority. So, we move here from 1 to 2 and 2 to 3. So, this is the anti-clockwise rotation, and hence the configuration is S configuration. But as given in our condition, lowest group must be on the vertical line. So here the condition is not followed, lowest group on the horizontal line. Therefore, this S configuration changes to R configuration, and the actual true configuration of this compound is the R configuration. Now, in next lecture, in next compound, you can see here. See, this is the carbon which attached to the two oxygen group. This is the carbon attached to the one oxygen group. This is actual oxygen, and this is the CH3. So oxygen having first priority, this carbon which attached to the two oxygen having second priority, this carbon 2 attached one having third priority, and this is the fourth priority. So we can move from 1 to 2 and 2 to 3, but the lowest priority group, that is CH3, is on horizontal line. So here is the R configuration, but due to the lowest priority group is on horizontal line, therefore R configuration changes to the S configuration. The actual configuration in this compound is the S configuration. This R configuration is not actual. The final and true configuration is the S configuration. In next example, you can see here. See, this is the amine group, this is the aldehyde group, this is the methyl group, this is the hydrogen. So these are the two carbon, one hydrogen and nitrogen. We know that nitrogen having 7 atomic number, which is more than the carbon atomic number, that is the 6. Therefore, ammonia having first priority, this aldehyde group having second priority, this methyl group having third priority, and hydrogen having fourth priority. So we move here from 1 to 2 and 2 to 3 via the 4. So we can see here the rotation is the anti-clockwise. Hence the configuration should be here, yes, but due to the lowest priority group is on horizontal line, the S configuration is converted into the R configuration. The actual configuration is the R configuration. In next example, you can see here all groups start with the carbon. See, here is a carbon, 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 and carbon, and all these carbon attached to the double bond oxygen. See here, this is double bond oxygen. If we expand this group, we can see here. See, this is the carboxylic acid. This is carbon double bond oxygen. This is OH here. This is carbon double bond oxygen. NH2 here. This is carbon double bond oxygen. CH3 here. This is the carbon double bond oxygen. OCH3 here. So when we doubt about the priority in such a way, we have to expand the group. Now we can see here the fourth group are the such a group which attached to the carbon, but this carbon, all carbon having carbon double bond oxygen. Therefore, we have to go further for the priority. Now we can see here this carbon attached to the oxygen next, this carbon attached to the nitrogen next, this carbon attached to the carbon next, and this carbon attached to the OCH next. We know that oxygen having the atomic number 8 and nitrogen having atomic number 7. See here, this carbon attached to the oxygen, this carbon attached to the nitrogen, and this carbon attached to the oxygen, and further CH3. Firstly, we have to compare these two groups. See here, this carbon attached to oxygen, this carbon attached to oxygen, but this oxygen attached to next CH3, and this oxygen attached to the hydrogen. Therefore, this group having first priority, this group having second priority. Now, in next, see, this carbon attached to carbon, but this carbon attached to the nitrogen. And we know that nitrogen having 7 atomic number and carbon having 6 atomic number. Therefore, this is the third priority, and this group having fourth priority. And hence, we move from 1 to 2 and 2 to 3. Now, this is R configuration, and least priority group is on the vertical line. Therefore, this is the R configuration here. In next example, you can see here. See, this is the carbon-carbon triple bond. This is carbon double bond oxygen. We can write this printed in such a way. See, this is carbon-carbon double bond and carbon-carbon single bond. It means according to the multiple attached to the 3 other carbon atom, carbon attached to the 3 other carbon atom, and hence, but here this carbon attached to hydrogen and these 2 carbon attached to the other carbon atom. Therefore, this is the pre-order to this carbon-carbon triple bond. Here, one group is oxygen, which having first priority. This NH, CH3 having second priority. This having third priority, and this carbon-carbon triple bond having fourth priority. So we move from 1 to 2 higher than 4 and 2 to 3. So therefore, this is the R configuration because the rotation is clockwise. But this is not in our condition. The condition is the lowest priority must on the vertical line. It is on the horizontal line. Therefore, configuration changes from SR to S. In next compounds here, this is hydrogen, this is chlorine, this is chlorine, this is bromine. So bromine is having first priority, chlorine having second priority, chlorine having third priority, and hydrogen having the fourth priority. We know that the atomic number of bromine is more than the chlorine, and atomic number of chlorine is more than the chlorine, and atomic number of chlorine is more than the hydrogen. Therefore, bromine has the first priority. So we move from first to second, and second to third, and third to fourth. Here, in this case, there is R configuration, and lowest group is on the vertical line. Therefore, there is no need to change the configuration. In next example, see there are 2 nitrogen and 2 carbon atom, and nitrogen having the atomic number 7, carbon having atomic number 6. Therefore, nitrogen having the first priority. This nitrogen attached to the next 3 CH3. This nitrogen having attached to the next 2 CH3. That is the, here are 3 methyl group. In this case, here are the 3 methyl group, and in this case there are 2 methyl group. Therefore, this having first priority, this having second priority. Now, out of this 2 group, this carbon attached to the next 3 oxygen atom, and this carbon attached to the next 2 oxygen atom, and hence it has third priority and it has the fourth priority. So we move from 1 to 2 higher than 4. So friend, you have to remember one thing. If 1 and 2 are in opposite side, then how to go from 1 to 2? Either from this side or either from this side. You have to remember that always go 1 to 2. When 2 is on the opposite side of 1, always go 1 to 2 from the side of 4 or via the 4 priority. So move here from 1 to 2 via the priority 4. 1 to 2 and 2 to 3. So therefore, this is clockwise rotation, and configuration is the R configuration, and the lowest priority group, that is the 4th priority group, is on the vertical line. Therefore, there is no need to change the configuration. Now, in last example, you can see here are the 3 phenyl group, but these 3 phenyl group having 1 chlorine here. So, in such a case, we have to measure the distance or the position of substituent here. See here is the orthochloro, here is the metachloro, and here is the parachloro. Obviously, orthochloro having first priority, then metachloro having second priority, and then parachloro having the third priority, and hydrogen having the fourth priority. So move from 1 to 2 and 2 to 3 and 3 to 4. So this is the R configuration here because rotation is the clockwise rotation, and according to our condition, least priority group is on the vertical line. Therefore, there is no need to change the configuration. So this compound having the R configuration. Friend, as we discussed the R and N configuration in Fischer Projection Formula, which having 1 chiral carbon atom. Now we are going to discuss the R and N configuration in Fischer Projection Formula, which having more than 1 chiral carbon. Friend, see, this is R and S configuration in Fischer Projection Formula, which having more than 1 chiral carbon atom. See, this is the first example, which having 2 chiral carbon This is first chiral carbon atom, this is second chiral carbon atom. Now let us first give the naming to this carbon atom. So this is first carbon atom, this is second carbon atom, this is third carbon atom, and this is fourth carbon atom. Now we have to observe, we have to identify first which are the chiral carbon atom. See, this carbon number 2 having 4 different groups. This is 1, this is 2, this is 3, and this is 4. Therefore, this is chiral carbon atom. This carbon atom 3 having 4 different groups. This is 1, this is 2, this is 3, and this is 4. Therefore, this is the second chiral carbon atom. Let us firstly discuss the RNS configuration for the chiral carbon atom number 2. See here, see this is the CHO is the first group, OH is the second group, hydrogen is the third group, and all this is the third group. So we have to observe the atom. See, this is oxygen, this is carbon, this is hydrogen, and this is carbon. So the group which attached to the oxygen is the first priority. Now these are the 2 carbon atoms. But see here, this carbon attached to 2 oxygen and this carbon attached to only 1 oxygen. Therefore, this having all this group having second priority, and now this group having third priority, and hydrogen having the fourth priority. So therefore, we can move from 1 to 2 and 2 to 3 via the 4. So we can see here this 2s, this 2 here is the anticlockwise, therefore this 2s, but hydrogen is on the horizontal line, so therefore 2s changes to the 2r. So the configuration is 2r. Now see here, this third carbon atom having 1 oxygen, 1 carbon, two carbon atom, and this is the 1 hydrogen. So hydroxyl group having first priority now. Now this carbon attached to the 1 oxygen, 1 carbon, 1 hydrogen, and this carbon attached to the 1 oxygen and 2 hydrogen. Therefore, this having the second priority here, and this having the third priority, and this hydrogen having fourth priority. So we move from 1 to 2 and 2 to 3 here. So this is 3s because the rotation is anti-clockwise. 3s is converted into the 3r. So the configuration is 2r, 3r here. Now, in case of the second example, see, this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4, carbon number 5. Now, see, this carbon number 2, 3, and 4 are the chiral carbon atom. In case of the chiral carbon atom 2, this is 1 oxygen, 2 carbon atom, and 1 is the hydrogen. So this hydroxyl group having first priority. Now this carbon attached to the oxygen by double bond, and this carbon attached to the oxygen by single bond, and therefore this CHO group having second priority, this group having third priority, and hydrogen having fourth priority. So we move from 1 to 2 and 2 to 3 via the 4, and hence the configuration is 2s because the rotation is anti-clockwise, but 2s is converted into the 2r because hydrogen is on the horizontal line. In case of the third chiral carbon atom, this hydroxyl group having first priority. Now these are the 2 carbon atom, but this carbon atom attached to the oxygen directly. This carbon atom is also attached to the oxygen directly. Therefore, we go further. See, this carbon atom attached to the carbon, this carbon atom attached to the carbon, but this carbon attached to the oxygen by double bond, this carbon atom attached to the oxygen by single bond. Therefore, this is the second priority now. It means this group having second priority and this group having third priority, and this hydrogen having fourth priority. So we move here the 1 to 2 and 2 to 3 via the 4. So therefore, this is the anti-clockwise rotation, and hence this is 3s, but 3s changes to the 3r because hydrogen is on the horizontal line. In case of the fourth chiral carbon atom, see this is hydroxyl group having first priority, and now this is the carbon, this is carbon, this carbon attached to oxygen, this carbon attached to also oxygen. But this carbon having all these groups, therefore this is second priority group, this is third priority group, and this is the fourth priority group. So we move from 1 to 2 and 2 to 3. This is clockwise rotation, and therefore we can write here this is 4R, but this 4R changes to the 4S because hydrogen is on the horizontal line. Hence the configuration of this compound is 2R, 3R and 4S. Now in this case we can see here are 1, 2, 3, 4, 5, 6 carbon atoms. So numbering this carbon atom, we can see here there are 1, 2, 3 and 4 chiral carbon atom. So about the 2 chiral carbon atom, hydrogen group having first priority, this group having second priority, this having third priority, and this is fourth priority. So we move from 1 to 2 and 2 to 3. So therefore this is 2s, which convert into the 2r because hydrogen is on horizontal line. So about the third chiral carbon atom, this having first priority. Now these are the carbon atom attached to the hydroxyl group, attached to the hydroxyl group. This is carbon double bond oxygen, this is carbon single bond oxygen. Therefore this having second priority. This having second priority here, and this hydrogen having second priority. This group having third priority, hydrogen having fourth priority. So we move from 1 to 2 and 2 to 3 via fourth priority. So this is the 3R, but it changes to the 3S. Now about the fourth chiral carbon atom, this hydroxyl group having first priority here, and out of this 2 carbon atom attached to the hydroxyl group, so therefore we move to the second carbon atom. Next carbon atom, this is CH2, this is CH attached to OH, but this having CHO, therefore this is having the second priority, and all these group having third priority, hydrogen having the fourth priority. So we move from 1 to 2 and 2 to 3. So this is R configuration. So we can write here this is 4R configuration, but 4R changes to the 4S because hydrogen group is on the horizontal line. Now in case of the fifth chiral carbon atom, we can write here this is first priority. Now this is the second priority group, this is third priority group, and hydrogen is the fourth priority group. So we go from 1 to 2 and 2 to 3. So this is the 5R because rotation is anti-clockwise and converted into the 5S. So here we can write the configuration is 2R, 3S, 4S and 5S. Then in the naming of such a type of compound, we have to remember one thing: the configuration of third carbon atom here, it changes because this third carbon atom is in between the 2 chiral carbon atom. Therefore this R should be smaller here. So in this case, these 2 chiral carbon atom R means the carbon atom 3 and 4 are in between the chiral carbon atom. Therefore this S should be small here. So we have to remember these things, these 2 things. Firstly, the least priority group must be on vertical line. If least priority group is not on the vertical line, then we have to change the configuration from S to R or R to S. And the second thing is, if any chiral carbon atom is present in between the 2 chiral carbon atom, then we have to write the name S or R notation in small letters. So in this lecture we have to we discuss that R and S configuration in Fischer Projection Formula having one chiral carbon atom or more than one chiral carbon atom. So we are going to stop here. Next lecture we have to discuss the R and N configuration in cyclohexane system and E and Z configuration. So we are stop here. Thank you.